May I suggest that if that everyone mute their speakers so that you don't have any competition? So if you go to the bottom left of your screen with your cursor, you should see a little microphone icon and click on that to mute it, and then our speaker can go ahead.
I also suggest you turn off your video because that will increase bandwidth. We'll have better reception if everybody does that.
How do you turn off your video?
Right next to the mute button, there's a little video thing.
Oh,
click on it and the line go through it. There you go.
Okay.
Okay, we ready then?
Yes.
All right. Well, I am Doug Tallamy from the University of Delaware, and today I want to talk to you about making insects. It's a guide to restoring the little things that run the world. So when I say making insects, I'm talking about creating environments that actually make insects. Why do we want to do that? Well, the phrase, the little things that run the world, comes from the great E.O. Wilson, Harvard emeritus at this point. I think he's 92, but he still writes a book every year. He told us way back in 1987 what would happen if insects were to disappear from the earth. And he entitled that paper, The Little Things That Run the World. And if insects were to disappear, life as we know it would change dramatically, because life as we know it depends entirely on insects. If they were to disappear, so would most of our flowering plants. And if most of our flowering plants disappear, that would change energy flow through our ecosystems so drastically that the food webs that support our animals, the amphibians, the reptiles, the birds, the mammals, even many of our freshwater fish, those food webs would collapse and all those animals would disappear. The biosphere, the living portion of the earth, would rot because we would have lost insect decomposers that right now rapidly turn over nutrients, and all we would have is bacteria and fungi. And of course, humans would not survive any of those drastic changes. So it was a pretty somber message, but this was 1987. And really, nobody was worried about losing insects. As a matter of fact, we were spending a lot more time and effort figuring out how to kill them all. And besides, if we depend on insects, why do we have National Insect Killing Week? Now, admittedly, that was 1929, but let's face it, our society hasn't changed much. This was a campaign to boost the sales of all brands of chemicals to rid the community of insects. And the message here is that all insects are bad, not just the pests, but they're all bad. Doesn't matter what they are, we're gonna kill them. And that idea still permeates our society. Even if we succeed in killing all the insects in agriculture, and we understand we might want to do that. And even if we kill all the insects at home, and there's not a good reason to do that, but we like to do it anyway, we still don't worry about losing insects overall because we think that they're common in our natural areas. There's two reasons why that's no longer true. And one of them is we don't have enough natural areas. This is what the night light map looks like of the US, and we're pretty much everywhere. We've turned those natural habitats into our cities, and they're certainly not designed to support insects. We've turned them into our suburbs, and they're not designed to support anything. Even our rural areas, the country, is not designed to support insects. Then we have agriculture. Rangeland, we've got 770 million acres of rangeland in the US, which is 4.5 times the size of Texas. That's designed to support cattle, but we always abuse it. We overgraze it, and it becomes very poor insect habitat as well. As a matter of fact, food production on planet Earth now claims almost half of the Earth's surface, and none of that is designed to support insects. The second reason that our natural areas are not supporting insects the way they used to is because they're not so natural anymore. Just about all of them are heavily invaded with plants from other continents. This is one of those natural areas near me. It's called White Clay Creek State Park. I took this picture in March a few years ago, when plants from Asia leaf out before plants from North America. And every bit of green you see here in this, quote, natural area is an invasive plant from Asia. And they're all escapees from our garden. Multiflora rose and Oriental bittersweet and Japanese honeysuckle and bush honeysuckle and miscanthus and barberry and privet and Callery pear and Norway maple and ailanthus, and on and on and on. About 1/3 of the vegetation in many of our natural areas is now from Asia, and it's very poor at supporting insects. As a matter of fact, invasive plant populations really destroy insect populations. And we'll elaborate on that in a minute. Now, when I was young, and many of you were young as well, You probably remember sites like this around every street light. That's what it looked like. There were insects flying everywhere. When we drove anywhere, that's what our headlights, our what do you call it, windshields looked like. They were splattered with insects. We don't see that anymore. So it's anecdotal evidence, but it's pretty convincing. We just don't have the insect populations we used to. We are winning our unofficial war against insects. And that's why we're seeing headlines like this. The insect apocalypse is here. What does it mean for the rest of life on Earth? Where people are now measuring global insect declines. They've done a lot of it in Europe, most of it in Europe actually, but we're actually measuring the disappearance, particularly of our native bees here in the US. And these are just a few statistics. Midwestern native bee species have disappeared from their historic range. About 50% of those species in the last century, they're gone from their historic range. We've got 4 species of bumblebees that have declined 96% in the last 20 years. And you may say, well, they're not extinct yet. True, they're not extinct yet, but they're functionally extinct. There's now so few of them, they are not performing their roles in the ecosystems. And of course, if you've declined 96%, it's going to take a lot to bring them back. There are 3 species of bumblebees that may already be extinct. It takes a long time before people pronounce them extinct, but nobody's found them in recent years. And 25% of our bumblebee species are at risk of extinction. As I said, in Europe, they've measured this a lot more thoroughly. 30% of Europe's orthopterans, the grasshoppers, the katydids, and the crickets are facing extinction. A lot of Lepidoptera, the Mausan butterflies, have declined or disappeared entirely from Great Britain. And Germany is where some of the biggest studies have come out of. There was one study that showed that there's been a 79% decrease in flying insects in Germany since 1989. There are 46 species of Mausan butterflies that have already disappeared from Germany. This is the most telling statistic down here. Invertebrate abundance, and that's largely insects, has declined 45% globally since 1974. And as insects decline, it's really looking like the birds that eat them are declining as well. State of the Birds Report 2016 found that 432 species of North American birds are now threatened with extinction. Not because there's only 5 left of each one, but because we now know that the signal of impending extinction is the rate of decline. And that many species are declining extremely rapidly. And this statistic for Mosenberg et al. Came out in 2019. We now have 3 billion fewer breeding birds in North America today than that should be 50 years ago, not 40 years ago. That's a third of the North American bird population gone. We actually went into the data set that Rosenberg et al. Used and divided the terrestrial birds up into 2 groups, the birds that require insects at some point in their life history, typically when they're breeding, and the birds that don't require insects. The doves and finches that can actually reproduce on seeds. They gained a few individuals over the last 50 years, but the birds that require insects on average lost 10 million individuals per species over the last 50 years. This doesn't prove cause and effect, but it certainly is suggestive that as insects decline, so do birds. Here are 2 species from Great Britain, the English sparrow and the starling. Now we see them as pests. They're doing quite well over here, but they're both red listed now in England because of the way they've sterilized their landscapes. So when you make your landscape so sterile that it doesn't support starlings or English sparrows, you know there's a problem. The UN now says that we are on the verge of losing 1 million species to extinction, possibly within the next 20 years. Let me just say, this is not an option, folks. I mean, they might as well say we're going to lose oxygen in the next 20 years. It is not an option. We have to make sure that doesn't happen. So that's the question. Does it matter? Well, you know, they're the creatures that keep us alive, and they're disappearing. I think that matters. It's very difficult. We've proven time and time again, and it's very difficult to convince human beings that we should react or proactively address a problem that seems to be long-term. In other words, we're very poor at reacting to long-term risks. If it's going to happen to us tomorrow, maybe we'll think about it. But we just, we tend to put it off. So I want to change the conversation. Rather than talking about what's going to happen to us in the future, let's pretend that we are the creatures that are actually in trouble, because we're pretty good at feeling protective of other animals. So right now, I want you to pretend that you are this bird. This is a magnolia warbler, and that's what you are. And you have just finished spending the winter, overwintering in the Tallamy Mountains of Costa Rica. And it is time for you to fly north so that you can reproduce, which means you're going to undertake the most dangerous thing you will ever do, and that is migration. Migration is dangerous for two reasons. The predation risks are higher. You're flying through a number of territories of predators. You don't know where they are. And the physiological strains of migration are tremendous. A bird will typically lose 35% of its body weight just flying across the Gulf of Mexico. Somebody looked at the stomach contents of tiger sharks a few years ago, and during migration, they were filled with migrating birds that never made it. They just fell into the ocean and the sharks got them. So very stressful physiologically. And then once they hit the land, the Gulf Coast, most of them don't breed in the south, they breed in the north, many of them in Canada. So they continue their migration north, and they will fly sometimes up to 300 miles in a single night. And again, they lose 35 to 50% of their body when they do that, their body weight. So when they stop, they have to come down. People say rest, but they really have to refuel. They've got to rebuild the energy they have just used. So migration is very stressful. It's very hard. You might ask the question, why did it evolve? Why didn't they just stay in the tropics? Well, it evolved for the same reason that anything else evolves. The benefits of migration outweighed the costs. So what are the benefits of migration? Well, of course, in the temperate zone, in the springtime, you have a giant flush of new leaves. And that giant flush of new leaves is followed by a giant flush of the caterpillars that eat those leaves. And caterpillars are driving the bird food webs, particularly in the spring. That doesn't happen in the tropics. The tropics are much more constant. There's no flush of resources. Competition is very extreme. So if birds fly north and take advantage of this bonanza of resources, then they're able to reproduce more in the temperate zone. And that apparently balances the risk of migration. If you stay in the tropics, on average, you can rear 2 to 4 offspring per year. But if you move to the temperate zone, that moves up to 3 to 6 offspring per year. And it may not seem like a huge difference, but it is enough to balance those severe costs of migration. So let me reiterate that bird migration was only adaptive because there were so many insects seasonally available in the temperate zone. How many insects are we talking about? Well, somebody, I don't know how they measured this, but they came up with this statistic. Birds are eating 500 million tons of insects each year. And they presented this as if, remember, all insects are pests, so that birds are great at pest control. Let's rewrite that and just say birds require 500 million tons of insects each year. And if we decrease the amount of insects available for birds, we're going to decrease the amount of birds as well. It has nothing to do with pest control. So when migration evolved, there were plenty of insects in the temperate zone. Is that still the case? Do we still have enough insects up here so that when the birds get here, they can justify that cost of migration? And every time we measure it, in most places, the answer is no. Let's just look at what the impact of non-native plants are on the insects that these birds use. We've been studying this for 15 years. We've got a lot of papers on it. We always get the same answer, but this is a very simple study I did with an undergrad not long ago that illustrates it pretty well. We went into hedgerows in Maryland, Pennsylvania, and Delaware and measured caterpillars along a transect in a standardized way in hedgerows that were invaded with non-native plants. So here's one heavily invaded with autumn olive and multiflora rose and all the others, and compared them to hedgerows that are uninvaded. They're almost all native vegetation. And what we found is that in the invaded hedgerows, the number of species of caterpillars was reduced 68%. The abundance of those caterpillars was reduced 91%. And the biomass, the actual energy, the measure of the energy in that ecosystem was reduced 96%. So when you're talking about biomass, you're talking about bird food. The bird food in these invaded habitats was reduced 96%. Well, if you take away 96% of the food for our breeding birds, that's got to have an impact. And it doesn't affect just a few obscure bird species. It impacts all of the migrants. We have 386 species of neotropical migrants in North America, and they may no longer have enough insects to justify that migration. We're talking about our swallows and our swifts, our orioles, our hummingbirds, our vireos, our tanagers, our buntings, our flycatchers, our thrushes, even all of our warblers. They're insectivores that need those insects. And don't forget the resident birds that aren't migrating, but they still need insects when it comes time to breed, like our chickadees. 6,000 to 9,000 caterpillars to make one clutch of chickadees, just to get them to the point where they leave the nest, where they fledge. And then after they fledge, the parents continue to feed them caterpillars for another 21 days. So if you want chickadees breeding in your yard, you have to have that many caterpillars in your yard, tens of thousands of caterpillars to make one clutch of chickadees. And if you don't, and you have to have them in your yard because the chickadee is not flying 5 miles down the road to the nearest woodlot. It forages about 50 meters from the nest. And if we don't landscape in a way that makes that many caterpillars, that's called insect decline. And it's certainly suggested that that is causing bird decline. Grad student Desiree Narango did a wonderful study on Carolina chickadees in the suburbs of Washington, D.C. And I will just illustrate what she found in terms of the importance of plant choice in suburban habitats. She was looking at how well habitats in typical suburbs support chickadee populations when they're dominated by native plants versus dominated by non-native plants. This is a typical territory of one of the breeding pairs of chickadees she looked at. The star is where the nest is. The red line represents 90% of the foraging territory of these chickadees. So they looked for food for their babies. 90% of the food was taken from within that red line. So it's about 50 meters from the nest. The blue areas are the trees on which they got all of those caterpillars. And if we look at what those trees were, they're all the native trees in this landscape: basswood, sweet gum, American elm, black cherry, and 2 species of oaks. But let's also look at the trees they did not forage on, and they're all the trees from Asia: Japanese maples and silk trees and ginkgos and black poplars, crepe myrtles, saucer magnolia. And it's very easy to picture a landscape that is dominated by those non-native plants that aren't offering either any food to the chickadees or not nearly enough so that they can actually fledge offspring. She also looked at the migrants that stopped by her plots as they were moving north, and there were 51 species that used her suburban plots as stopover points. So yes, they were resting after their night flight, but they had to gas up. And if they came down in the land of ginkgo that is making 0 species of caterpillars, they're out of luck. Because they can't gas up then, and they have so little energy left, they can't go looking for it. So, so the plant choice you make in your yard is very important, both for the breeding birds and the migrating birds. A lot of people say, well, I don't have a yard big enough to support a breeding bird, and that might be true. But if you have a yard big enough to support a single tree, and you make that tree the right choice, you can support migrating birds, and they will use your trees. So, very important. What if I said to you, introduced plants are reducing your bank account by 96%? I think everybody would get it, that's important. That's not sustainable. We can't tolerate that. Well, insects are the currency in our ecological bank account. It's our ecological bank account that keeps us alive. We can't afford to be knocking out insect populations to the degree that we are. So I think our only viable option is to find a way to live in harmony with the natural world, because it's a natural world that sustains us. We have to live sustainably in the natural world that sustains us. How are we going to do that? Well, let's first talk about where we're going to do that. We can't ignore private property. That's the property you and I own, because so much of it is privately owned. 85.6% of the land east of the Mississippi is privately owned. If we didn't do conservation on private property, we are going to fail, because then we'd only be working on 15% of the land, and that is not nearly enough to preserve enough nature to support the species that run the ecosystems that support us. So we're talking about properties like this that right now are designed exclusively for aesthetics. No ecological value here at all. How do we start making insect populations in a landscape like this? Well, first we have to understand what all the causes of insect decline are. Insect declines have been described as death by 1,000 cuts, because there's so many factors influencing insects. The misuse and overuse of pesticides, that's obvious. Habitat loss, general term, but it's everywhere. Habitat loss, so that picture I just showed of the yard, the plants in that yard are all non-native ornamentals, including the lawn. That's habitat loss because none of those plants are producing insects. And then many of those non-native ornamentals escape the yard, their offspring do, and biologically pollute all the land around us. They become the invasive species. 85% of our woody invasive plants are escapees from our garden. Light pollution is causing insect declines, and then finally serious challenges from climate change. There is some good news here though, and that is that the first 5 causes here are all relatively easily addressed by individuals. Each one of you can address each one of these. I'm not going to make the assignment that you have to solve climate change by tomorrow, but you can do a number of these things that will help insects almost immediately. How are we going to do that? We need to raise the bar about what we've asked our landscapes to do. In the past, we've asked them to be pretty. Cindy and I take a run every morning. We run past this house. It's still there. It's nothing but lawn. And if you like lawn, it's pretty, I guess, but it's an ecological desert. So the problem is that we have considered plants to be just decorations. So when we go to the nursery, we find something that's pretty, could be decorative, a screen, an anchor, a focal point, but it's all been about aesthetics. No thought at all to the ecological role that the plants in our landscapes have to start playing. And when we landscapes like this, we create beautiful landscapes that it equals ecological destruction. And when we do this everywhere, we've got ecosystem collapse. We could find pretty plants that actually produce ecosystem services, that support food webs. If you don't support the food web, you have no other living things there. That's a dead landscape. Protect our watersheds, store carbon, help the pollinators, help natural enemies, do all the things that have to happen in a regular ecosystem. We need to start thinking about the little ecosystems on our yard, landscaping them in a way that enhance the greater local ecosystem, as opposed to degrading it. Because when everybody degrades the local ecosystem, it is degraded. It's not functioning the way it needs to be. So when we landscape like this, where we add function to the criteria that we use when we select plants, then landscaping equals ecological restoration. And I'm going to call this 21st century landscaping. We've done 20th century landscaping, and we're now in the 6th great extinction. So I don't think that's worked real well. Let's give this a try. What does this have to do with making insects? We cannot restore ecosystems without restoring insect populations, at least terrestrial ecosystems, because they all depend on them entirely. So what does it take to make an insect? It takes energy. Same thing it takes to make all the other life forms on Earth. Where's that energy coming from? Well, the vast majority of it's coming from the sun. And of course, if you're looking for a miracle on planet Earth, this is a good place to start. Look to photosynthesis. Photosynthesis allows us and everything else to eat sunlight, which otherwise is difficult. It's difficult. They take the energy from the sun, combine it with carbon dioxide from the air, so that's good, pulling carbon out of the air, out of harm's way, and water from the ground, mix it up some very complicated chemical reactions, and produce the oxygen we all still need. And now the energy from the sun is locked up in the carbon bonds of simple sugars and carbohydrates, which is food. Plants are making nearly all the food on the planet, which means everything that eats food, which is everything, depends on that food that was harnessed by plants from the sun. So to make insects, first we need plants. Which insects should we make at home? There are a lot of insects out there. Or at least a lot of insect species, 3 to 4 million species worldwide. And I say 3 to 4 million because we're not sure, because we've only identified about 1.5 million of them. A lot of work still to do. There's about 164,000 species of described insects in North America. But I can still go out with a light at night and catch moths that are not described in my yard. So there's still a lot of undescribed species out there. But anyway, that's a lot of species. We're not going to save all of those right in our yard. So let's focus on what I'm calling the 2 most important groups of insects that are out there. The insects that maintain plant diversity. Plants are the first trophic level, and without that plant diversity, everything else is going to collapse. So those insects turn out to be really important. And those plants are going to capture the energy from the sun and lock up the food in their tissues. But if we don't get that food from the plants to other animals, it stays locked up in the tissues. So I think the second most important group of insects are the ones that deliver energy, take energy from plants to other animals. In other words, support food webs. So I'm talking about pollinators. Those are the ones that maintain the plant diversity that are out there. And caterpillars, it turns out, are transferring more energy to other animals than any other type of animal, not just insects. First, let's talk about pollinators. This, by the way, you know what that flower is? That's Virginia creeper. You don't even notice it when it's in flower, but boy, is it a magnet for pollinators. Why do we need pollinators? Well, if you listen to the news, it will say they pollinate a third of our crop. So the only reason we need pollinators is because of agriculture. I don't like that because that's so untrue. First of all, this part isn't even true. They pollinate about a twelfth of our crops. And pollination is not all about humans, believe it or not. Insects pollinate 80% of all plants and 90% of all flowering plants. If we lost our insects, if we lost our pollinators, we would lose 80 to 90% of the plants on the planet. That is simply not an option. It has nothing to do with agriculture. You know, I saw in I don't know, some magazine the other day. Oop, got to stay muted out there. They're working on robots, on little drones to fly around and try to pollinate our plants because they're planning on losing the pollinators. This is not the right approach. Technology is not going to solve this, folks. We need to make sure we don't lose the pollinators. We're not talking about good land stewardship in terms of keeping pollinators and other things around. We're talking about essential land stewardship. There is no other option. This is essential, very important. But to do that, we have to know what a pollinator is. You know, people think any insect that goes to a plant is a pollinator. Not so. Most insects that go to plants are what we call flower visitors. They are visiting flowers. They do use the pollen, they do use the nectar, but they're not transferring it from the male part of the flower to the female parts of the flower. So they are not actually pollinating anything. Who are our major pollinators? Well, we have one species of honeybee introduced from Europe. And it's excellent at pollinating, particularly our crops that were also introduced from other continents. But we have 4,000 species of native bees that did the bulk of the pollination, by far most of the pollination, before we brought honeybee over here. I mean, you know, we had plants that were being pollinated quite effectively before we brought over the honeybee. So these guys can do it, but we also have about 14,000 species of moths and butterflies, many of which actually are quite good at pollinating. Many of them are only so-so, but there's so many of them, and many of them are active at night. If you go out at night with a flashlight and look at your flowering milkweed or other plants that are in bloom, there are moths all over them at night, and they are transferring a lot of pollen. So even though they're not as good at it as native bees, we can't ignore these guys in terms of their contributions to pollination. Let's first talk about our native bees. Those are the ones that we absolutely have to save. But first we have to understand what a bee is. When I tell people we really need to redesign your property so that you can support native bees, they say, no way, because they're going to sting me. I say, oh no, they're not going to sting you. Most of our native bees, 90% of them are solitary. So they're not protecting a hive. They're not aggressive. They're not going to fly out and sting you. You can pet them when they're on a flower and they won't sting you. And people say, well, that's not true at all because I got stung last week. And what they're talking about is a yellow jacket or a bald-faced hornet. These guys aren't bees, they're wasps. They're aggressive social wasps that are protecting their hive. And I'm not saying we need to landscape in a way that produces more yellow jackets or more bald-faced hornets. They're predators, by the way. They're eating my caterpillars all the time. I'm talking about bees. Bees are not predators. They eat flower parts. They eat pollen and nectar. That's how they rear their young. So those are the ones, and they really are, except for the honeybee. The honeybee is the most aggressive one that we have. We want to increase the populations of these non-aggressive native bees right in our yard. Nobody's going to get stung. So how do we do that? Well, you have to give them what they need, a place to live and something to eat, pretty obvious. So let's first talk about where native bees nest. 3 places. Most of them are ground nesters. They nest in the ground, or they nest in little tubes. So woody stem nesters or pithy stem nesters. They hollow out the tubes of the stems and they nest within there. Let's first talk about ground nesters. 70% of our native bees are ground nesters. So if your property has any ground on it, and I'll bet it does, you can support native bees, at least some of them. And a lot of people say, well, my soil is really full of clay, and so therefore the bees can't dig down in it. It turns out there are bee species that can dig down into anything, including clay. So no matter what your soil type, you can support ground nesting bees. This is a little Calides bee. That's what a ground nesting bee nest looks like. Solitary, that's the female there. She comes out. They're very shy. As soon as a shadow hits them, they go diving in. And these guys are active right away. So they're the first bees you're going to see in the springtime. It's going to get up to the 60s next week, at least here in Southeast Pennsylvania, and we probably will see our Calides bees. They sink a single tunnel down into the ground and put some offshoots on the sides of that tunnel, pack them full of pollen, lay their egg on it, and that's how they reproduce. Then after they're finished, they close it up and the bees stay in there the rest of the year. Pithy and woody stem nesters, this is what they do. They hollow out the center of those stems. This is a picture from Heather Holm. And they first they pack a little cell full of pollen, lay an egg on it. The egg hatches, and this is what a bee larva looks like. Not much. It eats that pollen, completes its development, pupates here, and then tunnels out through the side of the stem. This one's younger, so it's a little bit smaller. This one's even younger, so it's smaller. And they continue down the row here, packing those stems full of their pollen cells. So where are they doing that? They're doing it in all of those herbaceous plants that have pithy stems. So our goldenrod, our evening primrose, you know, our New York ironweed, all of those things that during the wintertime die back, they look like they're dead and everybody wants to chop them down. That's what many of our native bees are depending on. Here's the trick though. They're not depending on it. So people say, well, I won't mow them down until March right now. Well, first of all, if there are any bees in there, that still kills them even in March. They're not out in March. But they don't start using these guys until the following summer. So it's the stems that grew last year that support bee nesting this coming year, which means you can't chop them down at any point without losing the bees. And that's why we recommend for your meadows that you burn or mow a third and a third and a third. So any one part of a meadow is only treated once every 3 years, which means 2/3 of your meadow is left intact, and that's where the bees are going to survive. Woody stem nesters are doing the same thing. Elderberry is a very soft wood, so it's easy to tunnel into. Here's what it looks like after all those bees emerge. But what do we do when an elderberry branch dies? It's a dead branch, so we prune it out. We've got to be neat. And you've just eliminated the nesting option for that particular bee. As a matter of fact, we don't allow any coarse woody debris to remain on our suburban properties. We got to clean it up. Fortunately, we have invented bee hotels that serve the purpose. They provide homes for things that like to nest in wood. And many of you have seen these before. Bee hotels are very entertaining for humans, and some humans go crazy when it comes to making bee hotels. It seems like a good idea because the bees do use them. There's all different size nests or holes here, so all different types of bees can nest. The problem is, and this is research that has come out fairly recently, is when we put all of our nesting options in one place, we're making it really easy for bee predators and bee diseases to find that one place, and then they wipe them out. So it is far better to not put all your bees in one basket and make small bee hotels and then scatter them in different places around your property. You shouldn't expose them to rain. They should be protected from rain. But that doesn't concentrate all the bees in one place. So if a predator finds them, it doesn't wipe out all of them at the same time. Not as much fun, but much better for the bees. Here's something I tried this past spring, I guess. So it's been almost a year. I cut off, I just got my loppers and cut off the dead stems. I'm not even sure what it was. I think it was goldenrod. And tied them together with a string. It took all of about 3 minutes, and then left them on the top of my wood pile for the summer two of them got occupied by one of those stem nesting bees. The rest weren't occupied, but they're still out there now, and then they have overwintered successfully. So that was real easy. You didn't have to have a drill or anything else, and it works. Okay, what do bees need to reproduce? They need pollen and they need nectar, of course. So we need to make pollen and nectar, and we need to make it all the time. That's the tricky part here. In New England, native bees are present from March now all the way through November. Not the same species, there's a sequence of species, but if you want to support the native bees in your area, you've got to have forage all the time, and that is a long period of time. It's the major challenge, is having a continuous supply of forage, of plants that produce the pollen and nectar. Because our bees aren't going to take 2 months off in the middle of the summer when you don't feel like having flowering plants around. What species of plants should we plant for the bees? Well, Sam Droege, he's Mr. Native Bee at Patuxent Wildlife Research Center, knows more about native bees than just about anybody else. He says, we need to plant for the specialists. We need to think in terms of the specialist bees, the bees that can only reproduce on the pollen of particular plant genera. The generalists can use those plants as well. So don't think about the generalists. They will find the pollen and nectar they need. It's the specialists we need to meet the needs of. And there's a number of reasons that bees are specializing. And by the way, about a third of our native bees are specializing. So that's, I don't know, 1,400 of them. They're specializing because flowers differ in all kinds of factors. They flower at a different times. They look and smell differently. Their pollen morphology is species specific, and each one of these little nungies on here is designed to grab the hairs of particular species of bees. So even though lots of bees will go to different plants, the pollen is designed for those specialists that are really good at transferring it. And they have very different nutritional value. So bees specialize, taking advantage of these different factors on different plants. And these are the top genera of plants in terms of supporting specialist bees in the Northeast, with native sunflowers very high, and particularly the, not the giant ones we make birdseed from, but the perennial sunflowers are very high. The various genera that asters were broken up into, goldenrods extremely high, willows very, very important, particularly because they are flowering so early in the season. And so on. Even violets are supporting an awful lot of species of specialist bees. So if you have a few of these plant genera in your yard, you can support dozens of species of native bees, of specialist bees. The generalists will be there as well. But if you don't have these, you'll just have the generalists and none of the specialists. Okay, that's all we're going to say about bees right now. Let's move to those caterpillars that are allowing our food webs to function. They are the bread and butter of terrestrial food webs. Again, they are transferring more energy from plants to other animals than any other type of insect. So if we design landscapes that is not rich in caterpillars, they're going to be dead landscapes. Most of the energy will remain locked up in plant tissues. So how do we increase the number of caterpillars in our yards? Well, you add caterpillars to the landscape by adding the plants that make them. And that seems easy enough, but there is a catch, and that is that most plants don't make a lot of caterpillars. This is elderberry, of course, wonderful bloom, excellent for the pollinators, makes lots of great berries for the birds later in the season, but it's really poor at supporting caterpillars. I don't know of any caterpillars that eat elderberry. There must be some, but I've never found any. So if you really wanted to support breeding birds, elderberry is not the way to go. Why are caterpillars so fussy about the plants they eat? Because plants have made them that way. Plants don't want to be eaten. They want to capture the energy from the sun and use it for their own growth and reproduction. So they loaded their leaves with nasty tasting chemicals, secondary metabolic compounds that make those leaves either bitter or downright toxic. And it's a really effective defense that keeps most of the insects of the world from eating most of the plants of the world. And that's why it's green out there in the summertime. It's not because there are no insects out there that want to eat those plants. It's because most of the insects that are out there cannot eat most of the plants. They are too well protected. But we do know that insects eat plants. So how do they do that? How do they get around those chemical defenses? This is black cherry. It's got cyanide in it. How's this guy get away with eating that? Well, this is where the specialization comes in. 90% of the insects that eat plants are host plant specialists. They can only eat the plants for which they have developed very specialized adaptations. They develop the enzymes that store and excrete and detoxify particular compounds, behavioral adaptations and life history adaptations that minimize their exposure to those compounds. It takes a long period of evolutionary history with the particular plant lineage for all those adaptations to fall into place. It does not happen overnight. Remember, each plant lineage is protecting itself with a unique cocktail of chemical defenses. A single insect species cannot adapt to all of them, so they pick one or two, and they get good at getting around those. Then they can't eat any of the others. That's host plant specialization. Crepe myrtle, for example, doesn't support any caterpillars. Why not? It's from Asia. It hasn't been here nearly long enough for our insects to adapt to it. And that's the problem with using non-native plants. They have not been here long enough for adaptation to occur. And if you think it's going to happen quickly, you have to think again. All of the evidence suggests it would be many, many, many thousands of years before these plants accumulated insect herbivores. All I'm trying to say here is that plant choice matters if we're trying to rebuild food webs in a functional way so that they support the life around us, particularly the insects. We have to choose the plants that do that because most plants don't. So for example, if I want the Pandora Sphinx at my house, I've got to have the Virginia creeper. I do want the Pandora Sphinx at my house because I like the Virginia creeper. I want to take that picture. If I want the tulip tree silk moth, I've got to have tulip tree. If I want sweet Luna moths, I got to have sweet gum. Now, Luna moths will eat different things in different parts of the country, but around here, it is sweet gum. No other choice. Zebra swallowtail. No matter where you are, a zebra swallowtail is only going to eat pawpaw. It's a very specialized butterfly on pawpaw. Native grapes support a lot of insects like the 8-spotted forester moth, but they're all specialists on there. If you have native viburnums, you can have the green marvel. Goldenrod supports 110 species of caterpillars. Beautiful things like the brown hooded owlet. Even poison ivy has specialists like the beautiful utilia. And I know what you're saying. Poison ivy, got to get rid of it. You know when you get poison ivy? When you try to get rid of it. Leave it alone. Don't touch it. Just your defense against poison ivy is to learn what it looks like and simply ignore it. If you allow the vines to get mature, then it makes berries, which are very high in fat. They're excellent for the birds in the wintertime. Persimmon supports the sculpture moth. These are just examples of the moths that these different plants support. The black gum supports the Hebrew. Ash supports a number of our big sphinx moths, which, by the way, are the primary food for cardinals when they're reproducing, like the fawn sphinx. I call that art in the garden right there. That's beautiful. Maples are very important. Rosy maple moth on maples. This is the royal walnut moth. It's my favorite large moth in North America. And according to Dave Wagner, they're now extirpated from New England. I don't know if Connecticut still has any or not, but you know, a victim of insect decline to be sure. You can get the double-toothed prominent on elm. You can get the witch hazel dagger moth on witch hazel. Pines support a lot of different moths like the imperial moth. Even our native clematis will support moths like the spotted thyrus. Two-toned ancillus on ironwood, the lost owlet on buttonbush, the herald on native willows, snowberry clearwing on coral honeysuckle, our native honeysuckle. The beautiful evening primrose moth, believe it or not, is on evening primrose. And this is what the adults do. They spend the day with their head stuck in the flowers. It's very cute. The showy emerald is on sumac, and I'm not talking about poison sumac. I've never seen poison sumac. It's a plant of the swamps someplace. The sumacs we're talking about, of course, are the native, the staghorn sumac or the smooth sumacs. Excellent soil stabilizers. You never have to turn to autumn olive or something else to stabilize your soil. Use sumacs. Then you have some real powerhouse plants. I call them keystone species, like native prunus, like black cherry. Will support the white furcula, the crocus geometer, the Io moth, the cecropia moth, the colorful zale. There it is if you can't see it. The tufted bird dropping moth. Who would not want the tufted bird dropping moth? You can have fun just saying its name. The paddle caterpillar. Send your kids out into the yard. Find a paddle caterpillar on black cherry and figure out what those paddles are for. Get them to think. There's no app for it. Thinking happens in your brain, not on your phone. What are those paddles for? They have a function. They're not there for decoration. It's the same function that these filaments on the filament geometer are serving. And don't tell them what the function is. As a matter of fact, I'm not going to tell you what the function is. I want you to think about it. Figure it out. The small-eyed sphinx. These guys are all on black cherry. Harris's 3-spot. It holds an umbrella of its shed head capsules over its head. And we know that what this is for a while, nobody knew. But if you go and you poke this guy, he starts whipping this around and whips you with his little umbrella there. So it's obviously a defense. And then the oaks, which are the most productive plants we have in 84% of the counties of North America, will produce things like the hag moth that thinks it's a tarantula, the red-washed prominent, the white-dotted prominent, the spiny oak moth, the skiff moth, the white-blotched heterocampa, the oak skeletonizer, the solitary oak leaf miner, the crown bucolatrix, the half-oval ancillus, the pink-striped oakworm, and my favorite, the spun-glass slug, and literally hundreds more species on our local oaks. Oaks, I said, are keystone plants. Remember the Roman arch? The keystone is the stone in the middle of that arch. If you pull it out, the arch collapses. If you take keystone plants out of your local food web, the food web collapses. And it turns out that just 5% of our native plants are making about 75% of the caterpillar food that drives our food webs. 14% of our native plants are making 90% of the caterpillar food. Those are the keystone plants. They're the 2x4s. If we're building an ecological house in our yard, you can't do without the 2x4s. You can't build it out of wallpaper. So oaks support 557 species of caterpillars in the mid-Atlantic states, 511 species in my county, Chester County in Pennsylvania. There's no other plant genus that comes close to that in terms of productivity. 900 species of bird food nationwide. Oaks are the best. You know where I took all those pictures I just showed you? I took them in my yard. That's what my yard looked like when we moved in. It had been mowed for hay. And the reason those species are here is because we put the plants back. This is what it looks like pretty much now in the summertime. I've been counting the number of moss species, actually photographing. These are the number of ones I have photographed so far, and I'm up to 1,031 species, which is more species of moths than all the species of birds in North America. We have 10 acres. Pennsylvania is 2.4 million acres. So on 1/240,000th of the land mass, we're supporting 40% of all the moths that occur in Pennsylvania. And because most of these are bird food, we've recorded an awful lot of birds breeding on our property. Why are they here? Because we planted all these guys, witch hazels and oaks and persimmons and American elms, all down the list here, and many more. But this is key too. We tolerated plants that most people pull out. You know, landscaper will tell you, well, black cherries are weeds, get rid of them. The second most powerful plant you can have in your yard. Ferns, great ground covers. Native grapes, very powerful. Tulip trees, not so powerful, but important. Virginia creeper. Nobody likes Virginia creeper. It's a wonderful native plant. Goldenrod suet, black willow, poison ivy, greenbrier, dodder, all these plants that everybody gets rid of are supporting lineages of moths that run the food webs that keep our ecosystems churning around. And because we've got all those moth species on our property, we also have the birds that eat them. 59 species of breeding birds recorded so far on our property. Things like the wood thrush. Wood thrush is a it's a bird of the forest. Remember our yard was mowed for hay? And we've been there 20 years now. So none of the trees are larger than or older than 20 years. But they're old enough to make the leaf litter that these guys like to forage in, and they have now moved in. We have breeding wood thrushes. Because we got Virginia creeper making lettered sphinxes, they love those sphinx moths. We've got indigo bunnies because we've got alders making ruby quakers. We've got chipping sparrows because we have black walnut making gray-edged bomolokas. We have field sparrows because we have oaks making red-lined panapodas. We've got titmice because we've got black cherries making dowdy pinions, phoebes because we have native grasses making skippers. We have robins, not because we have earthworms, but because we've got all those native weeds making things like the white-lined sphinx and many other moths that they love. Got Carolina chickadees because we've got tulip trees making tulip tree beauty. White-eyed vireos because we have spice bush making spice bush swallowtails. Caterpillars, we have house wrens because we have hickories making copper underwings. Bluebirds because we have sycamores making drab prominence. Again, 59 species of breeding birds on our property because we've got all that bird food. Point is that by choosing the right plants and using more of them, we could have yards that look like this. We could restore insects nearly everywhere. I'm going to leave you with 9 things you can do to make sure that ecosystem in your yard is a viable one by making sure you have lots of insects in your yard. And the first thing we need to do is thinking about cutting the lawn in half. We have way too much lawn in this country, about 40 million acres, which is equal to the size of New England in an ecological deadscape. Lawn's a status symbol. We're not going to get rid of it. So let's cut it in half. The area of lawn that you keep will still be manicured. That's not going to be our functioning ecosystem. It can still be beautiful. You can still be a good citizen, but we're going to put more plants in our yard. I went to the, I guess it was in Mississippi, and I drove by this church. I figured, you know, everybody goes to the church to worship God's creations, and on the outside of the church, they kill them all. We're just, you know, we're not thinking. We're just not thinking. If we cut the area of lawn in half, that'll give us 20 million acres to work with. In other words, we can create a new national park that'll be bigger than most of the national parks. It'll be the biggest national park in this country for sure, 20 million acres in size. I'm calling it Homegrown National Park, and you can join Homegrown National Park by going to our website, homegrownnationalpark.org, and getting yourself on the map. You can put in your data where you're shrinking your lawn and putting in native plants, and then your little area in your county will light up on the map. This is our attempt at social media to try to get beyond the choir, get people interested in restoring their yards. Okay, we also have to plant for specialist bees. We talked about that. We have to remove the invasive species that are on our property. Remember all those plants that are polluting our natural areas? They're coming from the plants we buy at our nurseries. So if you own property and it has invasive plants on it, it is your responsibility. It's just the most basic earth stewardship to get rid of those invasive species. And if everybody did it on their private property, remember, we'd be 85% done, which would minimize the seed rain from those invasives on our public properties. And then we could start focusing on those areas. These are the major invasive, some major invasive species in typical areas. English ivy has grown. When I first started talking about this, I don't know, 15, 17 years ago, I would go to talks and somebody would always be there talking about how English ivy is not invasive. It's invasive in Oregon, but not here. Wrong. It's invasive here. Now everybody knows it. They don't say that anymore. Calorie pear, one of the worst. Porcelainberry, probably the worst up here. It's just, you know, it's killing all the other invasives because it grows over them. It's a kudzu of the north. Burning bush, terrible and terrible everywhere, but particularly New England. The entire understories are burning bush. When you get into more southern places like particularly Tennessee, Kentucky, then the privets go crazy. Chinese elm, you know, get an American elm, don't ever get a Chinese elm. And we can go on and on and on. Okay, use keystone plants. We talked about that. How do you know what a keystone plant is? You go to Native Plant Finder on National Wildlife Federation website and put in your zip code, and the ranked list, ranked in terms of their ability to support caterpillars of both woody plants and herbaceous plants, will pop up for your county. So it focuses your plant search down to your county. Oaks are always going to be number one. Notice I say native oaks, native cherries, native willows, native birches, native maples. You can go to the nursery, and if you say, I want to buy a cherry, they're probably going to sell you a Chinese flowering cherry. If you want to buy a willow, they'll sell you a weeping willow from Turkey, because those are the things that are in the trade. If you ask for a birch, it'll probably be, you know, a European birch, or a maple could easily be a Japanese maple. Specify that you want a native maple, native to your area, because if you don't, you will have 65% less, fewer, 65%. You will have fewer caterpillars, cut by 65% if you use the non-native members of those native genera. And here are the most productive herbaceous genera in terms of supporting caterpillars, but these top three are also the most productive in terms of supporting specialist bees that we talked about. We want a landscape for caterpillars. We're just starting to think about this, but this turns out I'm convinced this is really, really important. Now, again, I live in Chester County, Pennsylvania. There's actually 511 species of caterpillars on oaks in Chester County, Pennsylvania. A few of them, like the polyphemus moth, complete their development on the oak tree. The caterpillar eats the leaves, then it spins a cocoon and hangs from the branch, then it emerges as an adult, and then it does it all over again. Everything happens on the tree. I wish everything did that, but most species don't. 94% of them, 480 of those species, drop from the tree and pupate in the soil. They wiggle their way beneath the soil and convert to a pupa underground, or they spin a cocoon in the leaf litter that is under the tree. The problem is almost everywhere there is no leaf litter under the tree, and we mow and compact our soil to the point where it's way too hard for our caterpillars to tunnel underneath. So this becomes an ecological trap. We're calling in adult moths to lay their eggs, the caterpillars develop, then they drop down and they die. And the next generation is smaller, and the next generation after that is gone altogether. I am convinced that the way we treat the area under our trees is another major cause of insect declines, which of course is a major cause of our bird declines. Remember that 3 billion birds that aren't here anymore. This is one of the reasons. And of course, the cement landscape is an even worse viable option. I'm not trying to discourage the use of trees in cities. I'm trying to discourage the profligate use of cement as a default landscape. We know it's a bad idea. It's laziness. It ruins our watersheds. And cement, by the way, is a major releaser of carbon dioxide, greenhouse gas. This is what most people do. They put a big tree in the middle of a lawn. Now, nobody's measured what caterpillar survivorship is in a situation like that, but I guarantee it's higher in a situation like this, where you have a tree in a layered landscape. Maybe you can have a dogwood over here, and then a native azalea, ferns and ground cover. It's a safe site. The caterpillars drop down. They can get below the ground because it's not compacted. Nobody's going to mow them. Nobody's going to walk on them. A safe site. This is where you can do your spring ephemeral gardening. This is how you shrink the lawn. You put beds around your trees and they become safe sites. This is where you can use your ground covers like wild ginger or mayapple or foamflower, any number of them. Ferns, don't forget your ferns, wonderful ground covers to protect make safe sites for those caterpillars. Reduce light pollution. You know, if we do succeed in making a lot of insects at our yard, particularly as caterpillars, they emerge as adults, but then we have these night lights on, we're killing them all. It turns out that there's a lot of research, particularly from Europe, that is telling us that light pollution is one of the major causes of insect decline. It kills them in about 15 different ways. Light pollution blinds a lot of nocturnal insects, and it messes up their daily activities and what they're supposed to be doing. So that's good news, because if we've identified a major source of insect declines that is as easily turned around as light pollution, we can get to it. Flick your light. It's a flick of a switch and you've saved insects. Nothing could be easier than that. But I know what a lot of people are going to say. I can't turn my light off at night because the bad man will come. Okay, put a motion sensor on your security light so it only turns on when the bad man does come. And the first thing you're going to recognize is that the bad man doesn't come very often. If you don't want to do that, take the white bulb out of your security light and put in a yellow bulb. Yellow wavelengths are far less attractive to insects than are white wavelengths. And yellow LED bulbs are the least attractive and certainly the most energy efficient. If during the summertime, if we switched out all of our garage lights and our porch lights with yellow LED lights, we would save billions of insects and billions of dollars. Oppose mosquito spraying. You know, if we do all the things that make our yard more attractive to insects, but then invite Mosquito Joe to come and spray, we've just reversed it all. This is a booming industry around the country right now. Mosquito Joe is effectively undoing everything I've been talking about for the last 15 years. And he will say, well, this is a natural product, so it's okay. It is a natural product. It's pyrethroids. It's from chrysanthemums. But cyanide is a natural product too. It doesn't make it okay. Mosquito Joe will also say it only kills mosquitoes. Not so. That is simply not the truth. It kills all the mosquitoes it comes in contact with. The big thing is it doesn't work. You don't try to control mosquitoes in the adult stage. You control them in the larval stage. In order to control mosquitoes in the adult stage, you have to kill 90% of the adults. Mosquito Joe kills 10% of the adults. He's not even close to being effective, which is why he has to keep coming back and back. He's also very expensive. So you're paying a lot of money for something that doesn't work. This is the way you control mosquitoes. You control them in the larval stage, and each homeowner can help by getting a bucket, fill it full of water, put in some straw or hay, and let it ferment for a couple of days. It becomes an irresistible place for mosquitoes to lay their eggs. Then you put in a mosquito dunk that you get at the hardware store. This is Bacillus thuringiensis. It's a bacterium that only kills aquatic diptera. You put it in there. The only aquatic diptera in your bucket is a mosquito, and the eggs hatch. They nibble on your mosquito dunk, and it kills them. If a dragonfly gets in there, it won't hurt it. If your dog licks it, it doesn't hurt it. If a bird drinks it, it only hurts mosquitoes. So it's very targeted. It's cheap, and if everybody did it, it would be much more effective than Mosquito Joe without eliminating all the other insects on your property. As a matter of fact, minimize insecticide use overall. Homeowners use a tremendous amount of insecticide. And if you don't believe me, go to the hardware store and look at all the stuff that is for sale there. The only thing that is essentially necessary is termite control. But all the rest of it is it's because of entomophobia. We don't like insects, but none of them are hurting us. So this is misuse and overuse of insecticides at home when it's simply not necessary. Finally, join your homeowners association. Infiltrate, change from within. A lot of people say we can't do any of what you're talking about because our homeowners association has rules and we have to follow the rules. Well, who made those rules? It was people. There's people who live there. You live there. You're a people. You can join your HOA and educate them. The rules that says we're not allowed to landscape ecologically were made in the 70s when we just weren't thinking about that. And we're thinking about status symbol. We want our neighborhood to be high status. Well, it can still be high status. Having a breeding chickadee in your yard does not make it low status. Okay, finally, I am going to end here with the way I started, talking about E.O. Wilson. In 2016, the book he wrote was called Half Earth, Our Planet's Fight for Life. This has been a major theme of his entire career, is to try to save life on Earth. And finally, he's running out of time, so he's not mincing any words. He says, if we want to save life on planet Earth, and he's talking about everything, including us, we have to have ecosystem function, preserve it on half of the planet. Half of the planet. Remember, half of the planet is already in agriculture. How can we do that? That means we have to, without getting rid of agriculture, we have to have functional ecosystems on the half that we humans are in. All 7.8 billion people of us, all the infrastructure, the roads and everything else. How can that be possible? Well, I actually think it is possible. I think we can realize E.O.'s dream, but we need a new approach to conservation. The old approach was humans are here and nature's someplace else. There is no someplace else now. Humans are everywhere. No longer are we going to exclude one another. We need to now have functional ecosystems, rebuild nature where there are a lot of humans. It's the only way it's going to work. And that's really what we're talking about when we're talking about saving insects at home. It doesn't mean that you have to save insects for a living, although it's a good living. You can save them where you live. Insect decline is a global problem, but it has a grassroots solution. It's something that everybody can contribute to. And if everybody does, we can turn it around. Thanks very much.
May we ask questions?
You certainly may.
What about ticks?
Well, they're not insects.
Okay.
Okay,
Yeah,
what about ticks?
ticks.
We have a tick problem because we have a deer problem. You're talking about deer ticks that transmit Lyme disease. When we were growing up, there was no Lyme disease. There were no deer ticks, and we had far fewer deer. So now we have deer way over the carrying capacity, and they are an essential part of the deer tick life cycle. So ultimately, that's the way we control our tick populations, to get those deer back below the carrying capacity. In the meantime, Ticks are not running after you, by the way. They climb up on vegetation. They put out their little legs, and it's called questing. And when you walk by, then they grab onto your pant leg or something. So during the peak seasons, and I know we can get ticks anytime, but the most dangerous time for disease transmission is May and June. Those are the times to be most vigilant. And that's why you should have swaths of grass in your property. That's where you walk. Don't go into the weeds during those times. And it's easy to avoid ticks that way. There are a lot of people that want to pave over their entire yard so they don't have any ticks, or get rid of all the plants, or poison all the mice. Mice are important parts of the food web as well. None of those things are ecologically viable. So you have to be vigilant. My wife and I are lucky because when we get a tick, it itches, so it tells us where it is, and you can pinpoint it. And I recognize that's everybody doesn't itch, so it is definitely a problem. But if you do get a tick and you identify it, pull it off and put Neosporin on the tick bite right away. Neosporin is not going to hurt anything. If the tick has not transmitted anything to you, so what? If it has, the Neosporin will kill the Borrelia beneath your skin. It sits there many hours before it actually gets into your bloodstream. A Lyme disease researcher at the University of Pennsylvania told me that decades ago, and ever since then, when we do it, we haven't gotten Lyme disease. Otherwise, I've had it 5 times, so I recognize that it's a real factor. So how's that for a non-answer?
Well, okay. The real question was, I do spray for ticks. I have had Lyme disease, and I'm very careful. Okay. And they only spray around the periphery of my property, and they use something which they tell me is not harmful to real insects. What is your opinion there?
I doubt that's true. If it's killing a tick, it's probably killing insects. But you just reminded me of something else that is supposed to work pretty well. And it's these, you put out these cotton balls that are impregnated with something, and the mice take the cotton balls back to the nest, and whatever's in there does actually kill the ticks on the mice. So the mice actually take the ticicide right to the source of the ticks. And I heard that works pretty well. I'll write that down. I've got to get the real specs on that for you. But,
that's Daminix.
Daminix
is the
okay.
product. Doug,
have you heard that it works too?
Very effective.
Doug?
Okay. Write that down, dear.
There's also, can I speak?
Well, Duncan was going there. I'll get you right after.
Doug, I want to say for everybody, thank you so much for your work. You have been so incredibly influential and meaningful to our group and to every landscaper I know.
Well, thank you, Duncan. Thank you. Okay, Sarah.
I was just going to say that mint oil, like just regular mint, and you put it in oil. There's a stuff from Maine called the Almighty No Bitey. That it's mint oil, and I put it at the bottom of my sneakers and over, on the bottom of my boots, and it's supposed to be really good for preventing ticks as well as mosquitoes.
Okay.
And it's just mint oil, so it's not toxic.
Right.
There's several mint oil ones. That's the one I can remember because of its name.
What's it called? Almighty No
Almighty No Bitey.
Okay, these are great suggestions. Thank you. Any other questions?
Sorry, hi. Hi, my name is Ashley. Hi.
Hello.
I was just listening to what they were saying about ticks as well. Again, along with the same question that the other lady had about spraying things in the yard, I had heard that cedar oil is really good at deterring ticks. So a lot of times if we do buy mulch for some of our, front area beds, we buy the cedar mulch instead. Seems to be helping. My dogs get ticks every now and then, but my husband and I have been okay. Just a suggestion.
Okay. Makes sense.
Also, will you have available the some of the slides or images? Because I'd like to get the list of native trees and plants that you were talking about.
Well, this is being recorded. So I imagine it's being recorded, so you guys have access to it. Although I
Okay,
don't know who's in
awesome.
charge of that, so somebody should tell you. Then you can watch it 1,000 times.
Okay, great. Thank you so much.
Right.
This was amazing.
You're welcome.
This is Holly Cosett.
I believe that this is going to be posted on the Mad Gardeners website shortly. You may have to be a member to see it, but it is going to be posted, I believe.
Can I just make a
Wonderful,
comment
thank you.
about cedar chips?
Yeah, go ahead, Holly.
Okay, I'm told by Emily May of Xerces that
Uh-huh.
may also repel good insects. The
That what does?
cedar chips, cedar wood chips.
Okay.
And the other thing is with the cotton balls.
Yeah.
Because bumblebees use the mouth.
Oh, right.
That's not good for them.
Yeah. Okay. Hadn't thought about that.
They do make a tick box that's enclosed. So
Uh-huh.
the mouse goes in and he gets sort of painted with the chemical. So he doesn't carry the mice.
Right. Okay.
So there's that. Thanks.
Okay.
Yes,
Great
I've heard of
suggestions.
I've heard of the tick box. That's a great, I've seen that before. Yes, that's
Yeah.
probably the best suggestion.
Good.
Could I ask
Good.
a question about your talk, please,
Yes.
regarding invasives?
Yes.
We have a lot of barberries on our property, and I had the nearby Audubon came around a couple of summers ago, and they were chopping them back and advised me to do the same, and then paint the remaining stalk with an herbicide. I'm just wondering if that's pretty labor intensive. The barberries we had easily 100 just in one patch of our yard. So I'm wondering if you have any other suggestions on how to deal with invasives in general.
Actually, it is labor intensive, but that is the surest way to do it once instead of 100 times. You can mow them and cut them back, but if you don't kill the rootstocks, they just come back.
Yeah.
So yeah, it is a lot of work. There's no doubt about it. And this is the serious downside to selling these invasive species in our nurseries, because they not just create a lot of work, they're, ecologically castrate our land, but the cutting and painting, it uses the least amount of herbicide in the most effective way. And don't do it in one day. Do one bush a day, and in 100 days you're done. And then it breaks it up into little manageable pieces.
Was it better, bittersweet?
Thank you.
I'd like to ask a question.
Yes.
Going back to the cotton balls, there is a problem with that. If the mouse eats or gets the chemical inside, if an owl or a nighttime predator catches that mouse, he is ingesting that poison.
Yeah, but I don't think the mice do eat it. It's external. It's a
Well,
topical.
the fur, wouldn't the owl?
Yeah, maybe. There's downsides to everything, I guess. So,
I know.
yeah.
I'd
Okay,
like to
watch
ask
out
a
for us.
question. Doug?
Uh-huh.
Hi there. I put this in the chat box, but I'm not sure if it's being monitored.
I don't think it is.
Okay. So I have a question about insect life cycles. So for instance, I see spicebush swallowtails building cocoons on the Lindera, in my neighborhood. It's a really neat thing to see during the winter months. I love it. And what I've always wondered about insects like that, because they're building a cocoon within a spent leaf from the previous year, so that whole structure gets pushed off as soon as the Lindera leaves out in spring. And what I'm wondering is, do those caterpillars actually emerge before that occurs, because that's quite early in the year, or are they getting pushed off when the shrub leaves out and then somehow completing their life cycle on the ground? That seems unlikely, since I think it would be exposed to too much moisture and predators and whatnot. But I've always been really curious about that.
Okay, there's a couple misconceptions there. First of all, the spicebush swallowtail is a butterfly, and it doesn't make a cocoon. It crawls off and makes a chrysalis in a protected place. What you're seeing are Promethea cocoons that are silked on to the end of the branch there, and they do stay there all winter, and they're wrapped up in a leaf, but they're tied to the branch by silk. So you can look, they won't drop off. and they'll actually stay there for a couple of years. And many times you find one, you see it's already emerged. So they don't fall to the leaf litter unless something's very wrong, but it's designed to stay on the branch. And then the moth emerges, hangs from there. The male, it's usually, if it's a female, the male will come, mate with her right on the cocoon, and then off they go.
Thank you. That's interesting. So then what kind of, I mean, I used the word cocoon incorrectly, and I realize that. I do know the difference between a cocoon and a chrysalis, but then what kind of a structure do the spicebush swallowtails create?
They don't create any structure. It's a chrysalis, so it is their exoskeleton. So if you can look up what a swallowtail chrysalis looks like. They lean back on a little silken girdle and attach themselves. So, for example, if you have a spice bush near your back porch, they'll crawl up under your back porch and hang back under there all winter. But they don't spin a cocoon or anything.
Yes, but if they do that right on the Lindera plant.
Typically, they crawl off. No.
Really?
They want to get away from their host plant because that's where the predators and parasitoids go. They go to hide. So that's why you rarely find monarch chrysalids on milkweed. They crawl off someplace else and do it. Most of the things, and often even the promethean moths and the cecropia moths and all those guys that are spinning cocoons, they'll crawl up to a half an hour before they actually spin their cocoon. So where you find the cocoon does not necessarily reflect where they were eating as a caterpillar.
Okay, and last question about this. If it is Prometheus moth chrysalises, or what's cocoon. The plural?
Well, it's a pupa in the cocoon.
Okay, sorry, I guess I'm getting confused here. In any case, when would at what time of year would they typically emerge? I live in Connecticut, so.
They have at least 2 generations a year, so they will emerge. The first ones can emerge, in Connecticut, I would guess early May.
Okay. Thanks. I'll go look.
And you know, they emerge. Promethea is very predictable. They'll emerge about 4 o'clock in the afternoon. So if it's a female, she'll release her scent, and the male will come, and then they'll mate when it's light. You can watch the whole thing.
Neat. Thank you.
Any other questions?
Can you comment on cockroach control?
Cockroaches in your house, you mean?
Yes.
Not much. That's urban entomology. I've never filled with that much. The cockroaches in your house are not the ones that are out in nature. It's the German roach. It's called the German roach because it's from France, and the French hated the German. The American roach is from Africa. It was brought over with slaving ships. Those would be the 2 most common ones that you might have in your house. Roaches are there because there's something to eat. The good news is they're not transmitting any diseases. So having roaches does not necessarily mean you are unclean. It often means you've got a pet, and they'll steal the dog food at night or something. But
excuse me, boric acid kills roaches. I grew up in New York City. If you spray, it's a stomach poison. They get it on their bodies. They bring it back to their nests. They get it on their mouths because they begin to eat, and they die. Boric acid.
So it's a white powder. You can put it along the baseboards.
Correct.
Right.
Works like a charm.
Thank you.
Thank you.
Yes.
I have around the base of my foundation, I feel guilty. I've had somebody spray for carpenter ants. Is there something I want to stop that? Is there something I could do instead?
Well, the carpenter ants are probably living in a tree in your backyard, and they come into your house to forage for food. And it typically happens in the springtime. You'll notice that they're around in the spring, and then they are gone the rest of the year. When you do that, you're living in an envelope of poison, Tom.
Okay.
And it's got to be pretty strong if it's going to kill the carpenter ant as it walks across it, just a little narrow band. So carpenter ants, by the way, are not hurting your house. they can hollow out wood that is already damaged. So if it's been damaged by water and they get dry rot, a carpenter ant colony can live in that. But they're not eating your house like a termite does. Termites do eat wood, and they can, you know, destroy your house, but carpenter ants can't. But most of the carpenter ant problems are not in the house at all. They're in a tree in the back of the yard. And you know, pileated woodpeckers rear their young on carpenter ants. So if you have carpenter ants, you can have pileated woodpeckers.
Thank you. Thank you, Doug.
Somebody else was asking something. Yes.
Hi. In the fall, well, late summer, I've had every year large black, I guess they're beetles with a little shiny, and they attract on only certain plants, but they cluster like mad, and then you never see them again for another year. And I've no idea. I tried taking them into a local nursery and they weren't sure what they were.
Well, if you could ever send me a picture or tell me what the plant was, that would really help. But
yeah,
you know what? It's not, you're not talking about milkweed bug, are you, on milkweeds?
No, they were on asters and
asters.
What
them
else?
on hellebores.
No, my hellebores have never had any.
I've seen them on hellebores, and it's the same time of year. And I used to know the name of the bug, and I can't remember it now.
Take a picture of it and send it to me.
I think it might be an American oil beetle. Cooperative Extension looked at some of mine that were eating hellebores.
Yeah, that sounds familiar.
Ah. Okay, well, you know more about it than I do. Oh, I think you're talking about meloid beetles, the blister beetles. I'll bet that's what you're talking about.
Yeah, they called it an oil beetle, but yeah.
Yeah, that common names don't mean much, but I'll look that up. But I bet that's what you're talking about. Yeah, and they can be common on goldenrod flowers. They eat pollen as adults. So
I had heard that chalk, using like a carpenter's chalk line around the base of your house, would discourage ants. I'm not sure about carpenter ants, but regular ants.
you know, if you used enough of it, like a 4 or 5 inch strip or something, I can buy that they don't want to walk in that. I would buy that.
Out of their house. And his whole talk was about promoting. That's true. It's funny.
Okay, you know, outside conversation.
Being against
if you're not asking a question, you should mute because we can't hear otherwise.
It's not a blister beetle. It's because those have yellow stripes. The one I have.
There's a lot of species, and most of them don't have yellow stripes.
Oh, okay.
You've talked about, hello, you've talked about carpenter ants. What about carpenter bees that are all over our house?
They're on our blueberries.
And on our blueberries as well.
Well, they're pollinating your blueberries. Well, and so are bumblebees. They look a lot alike. So that's important for pollinating the blueberries. But carpenter bees they're called carpenter bees because they are one of those tunnel nesters. They chew into wood and make a horizontal tunnel, and then they nest just the way I showed you pictures of in wood. They like softwood like pine. They love redwood. If you make a redwood deck, they'll do it in there, or sometimes the pine soffits of your house. It's a conflict. It's a good pollinator, but you don't want it making too many holes in your house. So, you know, people stuff the holes with anything, and it keeps them in there. But
it takes a long time to eat the house.
Thank you. Yes,
it does take a long time to eat the house. So.
Thank you.
Doug, I have a question about those stem nesting insects that you talked about, and the timing of garden cleanups, or whether they can even really be done at all. So I had certainly heard about leaving stems, or at least 12 to 24 inches of stem extant in the garden as long as possible. But I had not heard before that these stem nesters only use stems that are a year old, which is what I understood you to say. So first I want to make sure I understood you properly. Is that correct?
Right. This is the latest research coming from Heather Holm. And she's also the one that said if you leave 2 feet, that'd be great, because that's where they're going to nest. But so they're nesting in the stems that were created last growing season, but then they will also overwinter in them the following growing season. So the ones you have left there will have things in them during the winter time.
This doesn't really make sense to me because, I mean, I've been, gardening and also just a kind of observing plants in the wild for a long time now. I'm not going to say how old I am, but it seems to me that the stems of herbaceous plants that are a year old have already so significantly decomposed by 1 year later that they could not possibly be used by stem nesting insects. So I just don't understand that. You don't see multiple generations of stems of herbaceous plants when you go looking at them in the wild. You see the previous years. Everything else is already decomposed a lot.
It's a good point. I'm going to ask Heather about that and say, what about that? Because that is a very good point.
Okay. All right. I guess that's to be continued.
That's to be continued, right?
All right. And I do have one other question. So springtails.
Yes.
It's really interesting. I never saw, or at least was never aware of a springtail until maybe somewhere between 3 to 5 years ago. And suddenly I began seeing huge populations of springtails in December, January, anytime when it's not like really, really, really cold. And I'm not clear on why I would not have seen them until the last few years. And now the population of them just seems to be exploding. Right. And it's not just out on my property, it's elsewhere as well. So any thoughts on that?
Well, there's a lot of species of springtails. They're collembolans. But I had a similar experience this year. There's a family called Sminthuridae, which are little globular guys. And they're tiny, but for the very first time, we've been here 20 years, for the very first time, they were everywhere, all over our porch, all over the side of our house. We put out, a pumpkin, they're all over the pumpkin. I'm talking about hundreds of thousands. Never seen that before. And it was just, as a matter of fact, most years, Sminthurids are hard to find. So they're definitely doing well. There's 2 things that I can suggest, and it all comes down to moisture. We have had a series of, this probably doesn't apply to you, but we've had a series of really wet years where we've had a lot more rain than usual. And that, of course, encourages algal growth, and that's what they eat. So I suspect there's just an awful lot of food for them, and that's why they were going crazy. But Connecticut was drier than usual, right?
Maybe
Western Connecticut wasn't, but
I don't have a good, I can't really answer the question. I no longer work on client properties. So I don't, whereas I used to have a really encyclopedic memory of like the weather for the last 10 years. Yeah. I no longer have that, but
these collembolans are detritivores. They're eating detritus, the algae and fungi that grow on rotting leaves and any surface. So whatever is encouraging, I'm sure it's related to a plentiful supply of what they're eating and favorable weather. Okay. So when it gets, if you have a drought or something, boy, you don't see any collembolans. They go deep in the soil. So.
Okay. And then on that same topic, is there anything that predates on springtails, especially given the strange time of year when you see them out in number?
Yeah, yes, but they're also very small predators, little small soil predators. There are many collembolan specialists, a number of small, like carabid beetle larvae. Those are ground beetles in their younger instars. A lot of things eat collembolans. So yes, they are out there. But many insects go through boom and bust cycles where they just explode and then they'll crash and you won't see them for a while. It's one of the reasons that measuring global insect declines is difficult, because they vary so much. You have to have long, right. Time sequence of measurements to be able to document it.
Right. Well, thank you. Very interesting.
I have a question about whether or not you had to protect your property from deer in order to get all of your native species to thrive.
Yes, but I didn't protect the property because fencing 10 acres is more than we're going to do. So what I do is have small fence. I get the 5-foot galvanized wire that comes in a spool and at Home Depot or Lowe's, and then cut it to the size. If I'm growing an oak tree or something, I'll maybe make it 4-foot diameter. And then I just put it over. It keeps the deer out, and then I can move those cages around. I'm still using cages that I constructed 20 years ago, where I move them all around as I plant different things. But we have too many deer too, and it's a serious property. If I didn't protect what I wanted to grow, most of the time it would be gone. There are some things that they don't like, but not much.
That's what I've discovered too. They like pretty much everything.
Yeah, and the hungrier they get, the more they're willing to compromise. Okay, one more question.
What eats the green worms on hydrangeas? Anything good?
The green worms on hydrangeas.
Hydrangeas get these bugs of some sort in the summer, incredible especially, and then they form a web. And they're sort of crawling around in there. And does something good come along and eat them, or should I just get rid of them?
I'd love to know what you're talking about. If you're talking about fall webworm, I've never seen them on a hydrangea.
No, this is in the middle of the summer. They sort of arrive like larvae.
If it happens this year, please take a picture of it and send it to me.
Okay.
I don't have any on my hydrangeas, so
They're basically caterpillar larvae of some sort.
Yeah, sounds like it. Sounds like it. But there's not very many things that eat hydrangeas, so I'm interested in what it is.
Yeah, I'd love to find him if he would. Thank you.
Gypsy moth?
Yes, Kathy lives in Vermont.
No, not
Could it be
gypsy
some
moth.
northern species that you haven't come across?
That could be, sure. Could be.
Yeah, incredible hydrangeas are kind of common. The big, they have the ordinary
right.
hydrangea.
Yeah, I'd love to see what it is. And not gypsy moth. Gypsy moth is early season.
Could I slip in one more question?
One more question. Yeah.
Tent caterpillars, they have a very bad name.
Termites.
It's justified.
I'll do the termites later, but okay.
Tent
caterpillars, yeah.
Have a very bad name. Is it justified, and what can we be doing to contain them?
Okay, tent caterpillars are the ones you see in the spring. Fall webworms you see in the summer and later on in August. 2 different species. They're both natives. They both, have learned to protect themselves with webs, and that keeps a lot of their natural enemies out. They're both hairy caterpillars, which means most birds don't like them, except for the yellow-bill and black-bill cuckoo. They specialize on them. And I'll tell you a story about my tent caterpillars. Last year, I went around our property. I had 110 tent caterpillar tents. And one day, I heard a cuckoo. They're tough to see. They're very skulky. But I heard a cuckoo, and a week later, I went and looked at all 110 of those tents. Everyone was ripped open, and all the caterpillars were eaten. So if you get a cuckoo, they're real good at controlling them. But there aren't enough cuckoos to go around. In the old days, when these things evolved, the only place that they would do well is in a light gap or on the edge of a forest. Well, those are very limited places, or were. So there were never very many tent caterpillars or fall webworms around. Then we humans come along and we make everything a light gap. There's very few interior woods, it's all light gaps, so they go crazy. You never walk through a deep woods and see tent caterpillars. They're always out in the open. So we've created the perfect condition, and they do go crazy. They love prunus. They love black cherries, for example. They will get on your crabapple, prunus and malus, and they can strip it. It is my experience, though, that when the tree is at all healthy, it can handle it just fine. I had a black cherry in my backyard that was defoliated 10 years in a row, and I mean defoliated. Didn't even slow it down. A month later, all the leaves are out and it's fine. It's now growing way too close to the house, and I have to take it down. So the tent caterpillars didn't kill it. They do make ugly tents, and that's really what people object to the most. If you really want to control your tent caterpillars, look for the egg masses right now. They look like little barrels of styrofoam, brown styrofoam, wrapped around the branches, the very thin branches. They're pretty easy to find. Just scrape it off, and that is the way to control your tent caterpillars. Okay. Termites, was that a question? Go for it. This will be the last one.
Okay, so I live in the south, and there is the constant threat of termites. How do you deal with that without getting pest control?
You know you have termites.
No, there is a constant threat in the south. So how do you?
Yeah. You know, the standard termite control these days, it used to be that they would spray the perimeter of your house with chloridane, which is a chlorinated hydrocarbon like DDT. They don't, it's banned. They're not allowed to do that anymore. So what they do is put out termite baits. It's a block of wood in a plastic container. They bury it in intervals around your house. And then somebody monitors that maybe once every 6 months. They pull it up and see whether any of the termites are there are eating it. That will identify whether you have a colony. If you do, then they replace that wood bait with one that's impregnated with some insecticide, and then the termites eat it and take it back to the nest, and that gives a much more targeted control. But that way you're not putting out poison until you actually have termites. That's how the professionals do it. Okay, that's it. Thanks very much, everybody.
Wonderful.
Thank you, Doug.
All right.
Thank you.
Thank you.
Have a good weekend, everybody.
Thank you.
That was
Absolutely
great.
amazing as ever.
Okay.
Thanks.
Bye-bye.
Information.
Amazing.
Thanks.
Thank you so much.
Thank you.